Hello friends, today we are going to learn about a very interesting topic, that is ORF Finder. First of all, we should be aware about what is an ORF. ORF is an open reading frame. The region of a nucleotide that starts from an initiation codon and ends with a stop codon is called an open reading frame. An initiation codon is the triplet codon that codes for the first amino acid in the translation process. The translation process will start only when with the initiation codon. ATG, for example, which codes for the amino acid methionine, the translation process stops when it comes across a stop codon. There are three stop codons: TAA, TAG, TGA. Any of these codon can stop the translation. Genetic codon can form 64 triplets from the 4 nucleotides that codes for amino acids. Protein is formed from the ORF. Whenever you have a new protein, ORF, ORF helps us in finding or searching for open reading frames in the DNA sequence, or the program the program returns the range of each ORF along with its their protein translation. We can use the ORF finder for a newly sequenced DNA or for a potential protein coding segment. For this typical example, we are using human genes BRCA2 DNA repair associated with transcript variant 1 mRNA. We have used its accession number NM00059. We will go to Ncbi ORF Finder by typing in our browser ORF Finder. The very first link, if we click in Google, if we click it, it will take us to the ORF Finder page. Here we can type in our accession number NM00059, which is the accession number of Homo sapiens BRCA2 DNA repair associated transcript variant. You can type in here the accession number, or you can type the nucleotide sequence here in FASTA format. You can also use these fields for coordinates to mention the start position and the end position of your ORFs that you think that they can be present in this area. You can define the area by mentioning the coordinates here. We go further. We see here the minimal ORF length in nucleotides. That is, we are interested in ORF having length of 30 NT, 75, 150. It depends upon our choice what type of ORF we are searching for. We will go with the default one. Next is the different genetic codes. If you are not sure about the genetic code or the sequence, you can go with the standard option, or otherwise you may, if you have the information about the genetic code, you can pick up one of the options available here. If your sequence is related to any other organism like yeast, bacterial, or you are searching for a bacterial genetic code or anything else, you can, if the sequence is bacterial code, then you can select this 11 number option, bacterial, archaeal, and plant plastid. It depends upon your sequence, what type of sequence you are using. Next option is the ORF start codon to use. Default one is the ATG only. You may use ATG and the alternative initiation codon if you are not sure about that, your ORF only start with ATG, or there might be some other codons available which can initiate the protein coding, or you can go with the option any sense codon. This may continue with any codon which has the sense to start the protein coding. Here is the option that ignore nested ORFs. Nested ORFs, when we start the ORF search, you will see the sequence viewer, in which you will see that some portion of the ORFs will overlap, and some portion of the ORFs will be parallel in the visible in sequence viewer. You can omit this option, or you may continue this. I will check this option and click the submit button. After some time, this will display the result with the information. Here you can see that there are 28 ORFs has been found through the ORF Finder. We have used the genetic code 1 option, the standard one, and the stop to stop nested ORFs are removed. Now you can see here, you can see this window here. Here is the genome sequence viewer. You can see the red portion here, which is showing different ORFs. These are all 20 ORFs labeled here. We can see the further detail here. These are the ORFs. Here you can see ORF 6 having 3420 amino acids has been shown here. The sequence of the ORF 6 has been displayed here. If you think, you can see the length of different ORFs here and their start and stop positions. You can see, you can sort these ORFs according to their length. Here the ORF 11 is the smallest ORF, and you can see here the largest one is the ORF 6 with almost having length 10,263 nucleotides and having 3,420 amino acids. You can use this interface to select different ORFs. We think that if you are interested in some of the ORFs, you can select those ORFs. We will go with the longer one. Here is the longer one, is the ORF 6, which has almost 3,420 amino acids. This is the potential ORF which we will select here, and after selecting this we will mark it, and if we wish we can download the marked set in FASTA sequence or different sequence. We can also download it in CDS FASTA sequence or ASN sequence or feature table. If we want to download, we will click this download button and a FASTA file for this ORF will be downloaded. We can continue this, we can do different operation on this ORF by pressing the smart blast button. We can blast this ORF to find the related proteins already been discovered or already available in the different databases. The databases here, we can search for the protein blast are UniProt, KB and SwissProt, reference proteins, ref sequence protein, a non-related protein sequence NR. We will check the smart blast button. We will click the smart blast button to see the result of blast. Blast is a basic local alignment search tool. This will search for the potential proteins related to this sequence in the database. It's searching, it's taking some time due to the internet connectivity problem. Internet speed is not up to the mark today and it's taking time. Here you see. I think it's not working here. We will click again the smart blast. Once we have selected the protein, you can see in the sequence viewer the area of ORF6 has been highlighted in sequence viewer. You can see here, you can zoom to sequence at marker level. It is the longest ORF. You can see that it is starting with GTA, and you can see that complete sequence here and ending at we zoom in again, we can see the further details. We will come back to the smart blast page. Here you can see the results. It's showing the result. We see this option, breast cancer type 2 susceptibility protein isoform 1. It has been linked to, it has been closely related to breast cancer type 2 susceptibility protein isoform 1 Homo sapiens having 3418 amino acid protein. We can see the alignment by clicking the alignment page. Here you can see these. This is a query sequence, and here you see the subject one, the matching one. You can see these alignments here for your reference. Further proteins, you can see, if you scroll down you will see the different proteins, but the very first result will be the closest one. It has the identity almost 100% and 0% gaps, and it is the best match of the alignment. You can see here. Here you can see the alignment scores and identity matches readings here of the blast search. If we go up, we will see the E value, query cover, how much query has been covered, and the lowest E value means the best result, and the highest E value means the poor result. The higher the value of, higher is the value of E value, the poor is the result, matching result. This is all about the ORF Finder. These are the different ORFs found in this sequence that we used. It was the BRCA2 gene we used. We can simply blast it as well. but we have done the smart blast. This is all about the ORF Finder. If you have any queries, you can type in the comment section, and I will discuss it later if you have any problems. Goodbye.